Well, it says 12 volts at 3 amps, but there's a question mark. And here we see 12.38 volts. Well, that doesn't sound too bad. Ooh, that doesn't look so good. Here's the output on the looking on the scope. But what happens if we put a 10 ohm load on the power supply? Let's see what happens. Oh boy, that don't look good. Yeah, 18.6 kilohertz, 7.1 volts peak to peak. That doesn't look good. And now the voltage has dropped down to 9.3. So it looks like the question mark is right. So the next thing is to open the case, and most of these are ultrasonically welded, I believe, and I found the best way to do that, in fact I already did this one, is to use a utility blade at an angle and then strike it with a heavy object without going in too far, working my way around the perimeter. If you do that, generally with 3 hands, let's see, I think I'll put this on a tripod. Okay, it's on the tripod. So you split the case apart. It should come apart fairly easy now, which it does. And right away we see a bulging capacitor here, so that may be what our problem is. I will have to, well, it's kind of nice they got some shielding around it. I'll have to remove this shielding to get access to that cap. Well, maybe I don't. Before I go all the trouble to do that, maybe I should pull that cap, which I can get access and see what happens. There may be other problems with it, but that cap is definitely bad. There may be more of them in there. I think I'll open it up. Generally these will have another cap in there to many times they'll parallel caps to lower the ESR. So I'm gonna come back here once I open the case. Well, sure enough, that wasn't the only bad cap. All 3 of them were bulging. So I think what I will do, here's where the power comes in from the line. You got a bridge rectifier probably in here buried someplace. Then you got your main cap here, which will charge up to the peak of the power line, about 170 some volts. And then the switching regulator, it's like a regular switching regulator here. It will switch that current to be a buck converter, drop it down to the lower voltage, and then these are the filtering caps. So I'm going to replace these caps, and then we'll test it and see what we get. We may be okay on the line side here. Always be careful when you work on these. This cap's going to charge up to about, in at least United States, on 120 volt input, will charge up to about 170 some volts peak. So you always want to discharge that, which would have been these 2 terminals. I already did it. Anyway, I'll be back when I replace those caps. Okay, 3 new capacitors soldered in, and 3 bad capacitors 470 at 25, 680 at 25 times 2. Cheap caps. Guaranteed to work for 25 hours. Anyway, I'll put it back together and then we'll see if we get any smoke. Okay, I've powered it up and 12.38 volts. Now we have a nice steady DC signal. I'm going to connect a load on it right now. And the DC's looking good. We dropped to 11.93942. Coming up a little bit. But I would say that's pretty good here. Anyway, I'll let this cook for a while before I put it back together. But somebody threw this thing out in the junk because of once again bad capacitors. So that was an easy fix. These are nice little supplies. 12 volts at 3 amps. They can be used for a lot of things. So don't throw these things out. Generally, what you'll find is bad capacitors. Anyway, that was a quick fix, so thanks for watching. See you next time.